Internal combustion engines generate mechanical power by igniting a fuel-air mixture inside each cylinder. At cruising speed, thousands of controlled explosions each minute produce a tremendous amount of heat. Enough heat to melt the metal inside your engine. The cooling system allows your engine to run continuously in all types of weather, from the frozen north to the desert heat, without damage. That's a demanding job, since the engine will fail if just one part overheats. But it's designed to do more than just prevent damage. Properly maintained, the cooling system will keep your engine operating at about 200 degrees or 93 degrees Celsius, where it is the most fuel efficient and has the fewest emissions. A water pump is the heart of your engine's cooling system. On most vehicles, a belt rotates the pump, which forces coolant into passages inside the engine block, up through the cylinder head and out to the radiator through the upper radiator hose. As air passes through the radiator fins and coolant flows through small tubes within the radiator, heat is dissipated. Coolant then returns to the water pump through the lower coolant hose. A fan sits behind the radiator to keep air moving when the vehicle is at rest or when the engine temperature dictates. To help the engine heat up quickly, a thermostat restricts circulation to just the engine. When the coolant approaches the correct operating temperature, a special wax inside the thermostat progressively expands and allows coolant to be routed through the radiator. Under normal operating conditions, the thermostat is open only halfway, which allows it to respond dynamically to changes in engine temperature. It's important to use a thermostat with a temperature rating matching that of the OE recommendation. A separate set of hoses sends coolant from the cylinder head to a heater core under the dashboard to heat the passenger compartment when needed. Engine coolant is a 50-50 mixture of deionized water and glycol, along with a package of corrosion inhibitors as well as a dye to color it. In the beginning, coolant was colored to indicate what type it was. Today, coolant color is not standardized and not a good indicator of which type of coolant is in the vehicle. Glycol lowers the freezing point and raises the boiling point of the liquid, but not enough to protect the engine from damage. Coolant, for example, can reach 250 degrees near the cylinder head. To keep coolant from boiling at this temperature, the system must be pressurized. A radiator cap maintains an average of 13 to 15 pounds of pressure on the system when at operating temperature. The cap also allows the heated coolant to expand into an overflow reservoir or return to the radiator as it cools. In the 1990s, new coolant technologies with red, orange, yellow, or blue dyes were introduced to protect aluminum parts and extend the life of the coolant. Organic acid technology and hybrid organic acid technology formulations claim an extended service life of 5 years or 150,000 miles. On the other hand, many cars and trucks on the road still use traditional green coolant. To complicate matters, there are two major corrosion inhibitors used by most coolants: silicates and phosphates. American-made cars traditionally use both. European models contain silicates along with other inhibitors, but no phosphates. Japanese models traditionally use phosphates and other inhibitors, but no silicates. For that reason, mixing coolant types is not recommended, but is almost inevitable as cooling systems are routinely topped off when low or the system has been opened for repairs. When coolant is cross-contaminated, the inhibitor package no longer protects the metals in the cooling system, which may lead to rust, metal cavitation problems, and early water pump failure. To prevent cooling system contamination and water pump failure, and to reach the extended life advertised by new coolant technologies, new maintenance procedures and flushing techniques are required. Here's what you need to know. A good starting point for cooling system maintenance information is the owner's manual or maintenance guide for each vehicle, where a schedule of routine system flushing and coolant replacement is recommended. Following this schedule is important, since all antifreeze formulations, even those labeled as extended life coolant, wear out and must be flushed or replaced on time. Each formulation also has a specific package of corrosion inhibitors with a limited lifespan. Worn coolant with depleted corrosion inhibitors allows system chemistry to change, which can quickly damage components. Here's what happens to neglected systems. Rust and scale builds up. Worn coolant facilitates galvanic corrosion and cavitation problems in some systems. We'll talk about the damage each of these causes in a couple of minutes. In addition to a scheduled flush and refill, Many original equipment component manufacturers recommend additional maintenance steps and more frequent checks to keep the cooling system operating effectively, especially as the car ages. Those recommendations include changing wear items like the thermostat, radiator hoses, and heater hoses, as well as testing the radiator cap for proper pressurization and replacing as necessary, whenever the water pump or radiator are replaced. Doing so saves consumers the additional labor expense for those items later and reduces customer comebacks for the shop.